On the method of integration by parts, remember that if u and v are differentiable functions, then the integral of u dv can be written as u times v minus the integral of v du. Let's go over one example together. In this question, I gave you a ln of x squared minus x plus 2 dx. We're going to apply the method of integration by parts first. So let's take u to be ln of x squared minus x plus 2, and let us take dv to be dx. So we need to find the derivative of u, which is going to be 2x minus 1 divided by x squared minus x plus 2 dx. Well, v is equal to the integral of dx, which is x itself. Now, following the integration by parts pattern, the integral of u dv is u times v. So you end up with x times ln of x squared minus x plus 2. You can switch this multiplication around, minus the integral of v, which is x, times du, which becomes the integral of 2x squared minus x divided by x squared minus x plus 2 dx. To calculate this integral, please note that they have the same power, so you need to apply long division first. So far our integral is x ln of x squared minus x plus 2 dx. And here you have your quantity in the integral. So first let's do the long division. Here we end up with 2 plus x minus 4 divided by x squared minus x plus 2. So again, we did the long division for this quantity, and you end up with 2 plus the remainder, which is x minus 4 divided by x squared minus x plus 2. Now, to calculate this integral, we need to break this guy down into smaller pieces. The integral of 2 dx is just 2x. The rest of the integrals is the integral of x minus 4 divided by x squared minus x plus 2 dx. To calculate this integral, we're going to do a little bit of algebra. So far, we saw that our integral is x ln of x squared minus x plus 2 minus 2x minus the integral of x minus 4 divided by x squared minus x plus 2 dx. So let us break this guy down into smaller pieces. X minus 4 divided by x squared minus x plus 2. You cannot use partial fractions here because your denominator cannot be broken down further. But you can write this as x minus a half minus 4 plus a half. What I did, I just added and subtracted a half on the numerator. This guy can be written as x minus a half minus 7 divided by 2. I need x minus a half because eventually I'm going to complete the square down here, and you're going to see why we need x minus a half. You can factor out 2 and write it, and the way that you can see it is the derivative of the denominator. This can be written as x minus a half divided by x squared minus x plus 2 minus 7 divided by 2 over x squared minus x plus 2. So we just broke down this fraction into two fractions. Now, we're going to use the method of completing the square. X squared minus x plus 2 can be written as x minus a half to power 2 plus 7 over 4. Why is that? Because if you have x squared minus x plus 1/4, then you can group these together and have x minus a half to power 2. But the rest of it is 2 minus a fourth, which is 7 over 4. Well, let's see. Our integral so far can be written as x ln of x squared minus x plus 2 minus 2x minus a half to x minus 1 divided by x squared minus x plus 2 dx plus 7 divided by 2 integral of dx divided by x minus a half to power 2 plus 7 over 4. Right here, you can see how we broke this guy down into the completed square plus a constant 7 over 4. Let us continue, everybody. Our integral is written as x ln of x squared minus x plus 2 minus 2x minus the integral of a half to x minus 1 over x squared minus x plus 2 dx. Now I'm going to take 7 over 2 and write it in front of the integral. For the second integral, what I'm going to do, I'm going to follow the pattern for inverse tangent. If I have the integral of dx divided by x squared plus a squared, it's 1 over a. Inverse tangent of x over a, this x can be treated as a u as well. So if you take u to be x minus a half, you have u squared plus 7 over 4. So pay attention, a squared is equal to 7 over 4, and a is equal to square root of 7 divided by 2. At the same time, 7 over 2, the integral of dx divided by x minus a half to power 2 plus 7 over 2 to the second power can be written as 7 divided by 2 times 2 over square root of 7 arctangent of 2 times x minus a half divided by square root of 7. So keep this in mind because this is the integral that you have on the far right of this integral. So far we have x ln of x squared minus x plus 2 minus 2x minus a half. And the integral here becomes ln of x squared minus x plus 2. Why is that? Because if you take this guy as your u, then this guy is du. And the second integral, if you take u to be x minus a half, becomes square root of 7 divided by 2 du divided by 7 over 4 u squared plus 1. Very good. So our integral is nothing but x minus a half ln of x squared minus x plus 2 minus 2x plus square root of 7 inverse tangent of u plus c. And if you substitute u back, you get x minus a half ln of x squared minus x plus 2 minus 2x plus square root of 7 inverse tangent of u, which is 2x minus 1, divided by square root of 7 plus constant of integration. So in this question, you saw that we used integration by parts. We did a little bit of algebra. We took the integral using ln. We found the integral using inverse tangent, and we went back and forth using substitution a lot.